In this tutorial, I'm going to show you how to build a 3+2 table AC axis and 5-axis machine, 3-axis plus 2-axis rotary. And this is the information that you need to get just in case you need to make a post-processor. Here is some information about the X limit, the Y limit, the Z limit. Yeah, if you have this dimension, it will be good, and also this one. And this is the tilt rotary axis. So you have to check the machines. This axis, the axis character, the name is A or B or C. Okay, let's assume this one is A. And you also need to check when turn clockwise this direction, is it plus or minus the angle. And also other details about this one is the tilt rotary center to the table. What is the distance? From the PDF is 19619, and the distance from the table 0 center to the rotary axis, to the tilt axis, it will be 50.8. And also you need to check the C axis. So if looking by the top, from the top, look if the rotary axis is rotate clockwise, what is the angle? Is it plus or minus? So in this case, is a minus. And again, sometimes the machines, most of the time this is C, but sometimes it's not C, so it's A or B. So you need to make sure you get the correct information. Now let's start the tutorial by dragging in this file, the step file. This is the machine file that you can get from the machine supplier, right? And sometimes you may have a very complex file. If you have a complex model with a lot of surfaces, the simulation will be very slow. So it is good to simplify the model by remodel the machines if needed. For example, I remodeled the base. Right, the original base is very complex and consists of many surfaces. This will slow down the simulations. Okay, so the spindle is 610 from the information here 610, and so I'm going to move it. So make sure you are inside the XY plane, and use Ctrl key to select 2 solid block, then go to translate 610. Yes, right. I'm going to set my machine Z home position here. So the X0 and Y0 in this case I will set at the center of the table center. That means if I'm going to load the part will automatically use this 0 point. Yeah. Now let's import the rotary model. And as what we have explained just now, the part 0 point, or the rotary table top center, has to be the reference point. So we cannot move the rotary, but we can move the machines. And we're going to move the machine by this value, 50.8 plus 196.9. And let's select the whole machine. and do a translate. So the value is 247.7, and let's assume the lottery is fixed at these locations. Next, I'm going to show you how to enable the plugin for Machine Manager that used to edit MDD file. What is MDD? MDD stands for Machine Definition File, something like that. This is MDD. So for each type of machine, you will have one MDD file, and this file will tell GibbsCAM that what is the axis. Do you have X or Y or Z, or A or C or B or C, something like that. Normally, where is the MDD file stored? It is stored under, you can go to plugin and go to Pathfinder. So it is stored normally under all user MDD folder. So you can double click, and here is the MDD files. For me, I have a lot because I play with quite a lot number of machines. Right, these are MDD files. So we're going to create our own for this HAAS machine with a 2-axis lottery table. Yep, let's close it. Now I'm going to show you how to enable the machine's manager under plugins. So as you can see now, I don't have any machine manager here. In this case, what you need to do is go to the plugin manager, right, and go to find the plugin. So this is the machine manager. So you just click OK and apply, and make sure you save the file. And to enable to load the machine manager, you need to restart GibbsCAM. So I'm going to close it. Yes. And restart GibbsCAM. Right. Now let's open back the files, the file that you saved, right, this file. And now if you go to plugin, you can see the machine manager here. This is the machine manager. Before work with the machine manager, first we need to give a name to the component before we continue. So let's select this one and show property. So this one I can rename it as base, and to change the color, make sure you unselected it and right click here and use the color. So I'm going to choose a dark gray. Right, so this is the spinner. Let's just spin the do the change the color. Make sure clear selection and right click here, use the color. I'm going to put my spinner maybe this color. Yeah, the Z-axis, actually that's Z-axis. I'm going to rename this Z-axis, and this is a spinner. So I'm going to check plugin spinner. Again, change the color of this to maybe this color. Yeah, you can choose any color you want. And how about the Y? This is the Y axis. So show Y axis, and I'm going to set it gray as well. So it's gray as well. It's dark gray. Okay. And this is the table. The table is the x-axis. So I'm going to set x-axis. Right. Share property. Maybe this one. Sorry. Using color. Maybe this one. Which put it white. Maybe. And this body here. Right. Rename it to road body. Right, and which color? Go to that color as well. How about this? This one is the tilt axis, so it will be, I'll put it a-axis. Let's change the color. Let's use white. And this one, A body, I'm going to rename it A body, and its color maybe about dark green, yeah, okay. And then this will be the C table, and C table, let's change the color to okay, white. Right, I think we color everything and save. Now let's go to the plugins and click on the machine manager. You should have this because the 3-axis vertical mirror entity is locked. Just click OK, because what we need to do is create a new one. So click on new, and you can put this my HAAS 5x, any name you can give. Choose 5-axis, and this is what is a AC. A means that the rotary axis for the tilting axis is parallel to parallel to X. C is the table rotary axis parallel to Z. So we're going to use AC, and just create. Immediately you have some examples, or you can call it examples, yeah. Or you can create one by one if you want, right? So let's just use the default. And what else? No, for 5-axis only, we don't need VMM. Yeah, machine simulation folder. So where's the machine simulation folder? So I will put this new folder, my HAAS 5x, and post versa, forget it for now. So part file, right? So to link the part file, you need to open back the file that you saved just now. There you are, right? And then save. So after save, then you will have one NBD, a new one called my HAAS 5x. And what is ABC axis? This picture here will show you very clearly. A means that is the load 3 axis rotate around the X, B is around Y, C is around the Z, right? If the rotary axis rotate, if looking from these directions anti-clockwise, that means it is a plus axis. If it is counterclockwise, and it will be the a minus axis. So this is how we differentiate. Now let's go and go back to the machine manager, and we're going to add in the base. Select here, select the base, select here, add child, and add simulation body. So is the base, and we need to assign the collision group and visibility groups also, right? And then we need to create this group under this here. So here normally you create one head group. This is for collisions, and another one will be is the table group, right? Two group. Visible group, you also have like head, table, right? And you may have also others, right? So let's select this base. So I'm not going to do any collisions checking on this, so I will not select any of it. And this base I will assign it to, for example, to the others, yeah, other visibility groups. And next it will be the z-axis, right? So I'm going to select here, add child, and here for the z, yes, it's belong to, I want to have collision checking. It's belong to head, and also I'm going to set the visibility groups to head. And next will be the spindle. Select this, and same place, the Z. So simulation body, spindle, yes, I need to set head, and also this is the head. Right, and for the z-axis we already see there's a limit. Machine limit is here 610 and come down to 102, right? So, and we already moved the component, so now it's at 610. So the maximum limit is 0, and 610 minus 102, yes, 102, 102. So it will be, the minimum will be minus 568, and send the direction vector, yes, standard Z. It means that if I put plus some plus value, the spindle will move up. So that's standard. And after you have set this, you can test for it. Let's go to test machines. Yes, I will save this MDD. Right, so let's minimize, and like that. Right, so we have a z-axis now. You can test it like that. Now let's add the y-axis. This will be my y. Geometry, simulation body, y-axis, and y. No collision check, and I will put to others. And this table is the x-axis, so add simulation geometry. Yeah, collision check. I'll put set as a table group and table. Right. Then let's check what is the axis limit for the y. For the y will be plus 228 minus 178. Plus 228 minus 178. For the x, and for the x is 381381. Minus 3881 and 381. Right. Then we can test the machines. Yes. So now you have y. So y plus and y minus x plus x minus, right? You can see that the direction vector for the component is actually minus 1. Okay. If you change the center x, then you will be opposite the directions. Let's add the tilt rotary axis, the a-axis. So this one will put on the x geometry. Okay, so it will be the table and table. The x and this is the A, this is A, and this will be the table and the table, and this is the tube body, and okay, so this will be the table and also the table. So now let's check. Something is wrong, right? Yeah, so we need to do some settings. Let's come back to here. Let's look at the a-axis first, right? Let's look at the PowerPoint of this one. So this shows that if looking from this direction, rotate clockwise, it will be plus angle. So the axis will be a plus axis. Okay, a plus axis. So the first thing that we need to modify is this one, change to the standard A. So the x1, the vector is 1 plus, and also the pipe point. Yes, here we need to key in the value of this D1 value, from the rotary table top center to the tilt axis center. So it will be 50.8. okay, and also sometimes the rotary table is not exactly at the center, then you have to key in the off center value as well, either y plus or y minus. So the vector is 50.8, so it should be minus 50.8. Right, now test again. A-axis, and yes, the direction, this is plus direction, and now the rotary looks okay now. There's no funny movement. Right, the next is to set the limits. What limit? Normally this kind of axis you have a limit. Let's check. The limit don't mention here, but normally is around 120 plus 120. So let's change, apply the limit, minus 120 and 120. That is the tilt rotary axis. Let's make it safe. And let's test machine. And you can see now the limit is set to 120 to minus 120. Now let's add the remaining. There we will see here, add the charts. This one C table, correct? And there's a table, and it is a table also. Okay, that's a C, and from the data given here, the C clockwise will be minus, clockwise minus, that means that axis is C minus axis, C minus. So the vector should be minus. Yes, correct. This is minus axis. And test. And now we have to see. For the C-axis, we have to check properly whether this rotary axis support shortest path or not. Okay, if it is a shorter path axis, then there's no limit. Okay, and if it is not, then you have to set the limits. What's the maximum, minus, and plus limit. So let's assume this machine, the rotary, has a shortest path axis. How to test on the machines to see whether the rotary axis is a shorter path or not? It's simple. You just go to MDI and key in this code Z00C0 to move the C to 0, and then the next block move it to C350, and you have to notice the movement. If the movement, the rotary only reverse 10 degree, it move only 10 degree in reverse, that means the rotary is shortest path. Right, so if reverse 10, shortest path, if it move 350 forward, and then it will be non-shortest path. For shortest path, there's no limit. If non-shortest path, there's a limit. You have to find out what is the limit. And this is a C. Now we have done creating the MDD with all the axes. Next is what we need to do is to create some a box to test the movement. For now, we just hide everything, all the components. We're going to see this here. Right. And I'm going to create a box, maybe with x dimensions 100 and y dimension 50, and click OK. Right. So to adjust the view, I can go to modify and string wrap visible, so it will fit to this. And then I will create a solid object, minus 50 will be good enough, right? Let's do this. Okay, so if I go to the machine simulations, you can see this. The stock is actually under inside, right? Uses the 0 points here. So we need to do some adjustment. So the document control, and this you need to move up. So you need to set this value accurately. It will affect the Z code. So I will set the fixture, maybe height will be 100, right? And you can go to preview again. Right, so somewhere here is okay. and I'm going to set this one, set show property, set it to as a stock. Right, and we are ready to do some machining. Next, let's create a first a profile on top. Just create a new tool, bono tool. This dimension is okay. Let's create a profile, and RPM, any value is okay. So it's XY, make sure it's positions, and the height is 0 is. So just create a profile on the profiler. Right click and profile is -10. Just make a section for me, and just do it. And this is the profile, and then you can simulate. Use the machine simulator, right? Make sure you click on the machine simulator, and okay, then you can place step by step. Yeah, there's something show holders. You can see there's a problem. The holder is not on the spindle. Is something wrong? Yeah. Why is this? Because we forgot to set something in the MDD. Okay, so we need to find this distance from the spindle face to the table, the rotary table. So the value will be 610 minus 50.8 minus 169.9, so it's 389.3. These two values is from here. Is D1 and D2 dimensions. So 389.3. So let's go to MDD and go to tool. Make sure you select the tool. Right, this is under orientation tab. Here you put the value 389.3. 389.3, and then let's save, make it save. Right, and now let's go to simulate again. The problem should solve. Yeah, now the tool is on the spindle face now, so I mean the problem is solved. So you can step 2. Right, this is correct. And then now let's do a profile somewhere in front. Let's delete this, and let's off the profiler, and then we go to we need to create a new UCS here. Let's create a new coordinate system. Let's say put front, and I'm going to modify this CS by the CS palette. Just choose this face, and you can see that plus means that my cutter is coming from the front. Yeah, so this is what we want, and we're going to do some machining. Let's change this one. Let's on the profiler. change the CS to front on the profiler. You can move the profiler if you want. Just click on this here, create a new one, and this time is the front. And let's capture the height. Use alternate key. Capture this height. Also here, this height. 25. Let's put 30. It's good enough. Give it 100. The rest is okay. Let's choose this control and do it. So now I have a profile in front. Right. So to cut this profile, the rotary can the tilt axis can tilt either the plus or minus side, right? So if you don't set any, let me right click this position, set rotation preference. Right? If you don't set any value, then the system will decide, will choose for you. So let me do a simulations, and I just select this one, and I'm going to use this one, skip unselected all, so that I can only select this. And you can see now it is working on this side, right? The plus side, the minus side, yeah. The plus side is this direction. So yeah, now it's working on the minus side. Okay, we can control this to set by setting this value. Okay, what's the minimum and what's the maximum? And most of the time we'll, under the MDD, we'll create some preferred angle, right, for the working area. So how to create this one? Let's go back to here. And go back to A axis. Oh no, yeah. Machine preference, work area. So you can create that. I'm gonna use the second. So this will be A plus side. Right. So A plus, and this will be maximum 120. I can add another one, work area, A minus, this is minus 120 and 0. So this, the user, we let the user choose one of these. Yeah. Let's make it safe. And then here we can set the preference. Now I can choose one of it. Yeah. So for this machine, it is good to use the X minus side, because the travel of the Y is more. That means you can machine a higher part if you work on the minus side, right? So but now I'm going to choose the plus side, right? And let's step 2. You can see now the rotary is working on the plus side. Right? So I'm going to set back to the minus side. Now let's simulate all the procedure. This is simulations. And let's cancel this so that we can simulate all. And steps. Let's rewind again. You can see here there's a problem here, but the starting point is too close to the part. Why is this? And because of this one, the clearance, right? So let's put 30 mm and try again. Rewind. And come back. Now you have 30. So don't forget to adjust a proper clearance. Now we're going to test for two change positions. I'm going to modify this procedure and create a second tool. Just change tool and redo. So now I have two procedures with two tools. Okay, and go simulations. Let's rewind. Right. By default, currently we don't set any two positions, right? That means the default is not two change positions. So let's do finish. And next procedure, we retract up to maximum. This is the original point from our model. Then change. So this position is supposed to be two change positions, right? But in fact, that's not the case. So how to control the two change positions? Yeah, we can control by this parameter here. If you allow it to change in the MDD, and here's the two positions. So you can set. You can set like my two going to change at position this Y and X refer to the table top center. So if I on this and simulate again, let's rewind. Yeah, you can see now the two actually start at the position that we specified, the two change positions, and come down and do the thing, cutting, and for the second two change, you go back to that position also, then come back and do machining. That is the two change positions. Next, we're going to fix the two positions in the MDD. Before that, we need to move some component. So currently, we need to move, for example, the X. Move the X to move the X by 381. That's a two change position, so we can only move the machine component, but not the 0 point. Go to make sure this is XY, and we'll modify and translate. So we'll move 381 minus 381 and move right. This is X. I put a Y. The Y will be 228. As seen in this drawing here, 228. And it should be 228. Right, this will be our new to change position, or our machines to change positions. Next, open up the machine manager, and then we need to delete something. For example, the base, we need to delete it. We attach the base, simulation body, base, and its others. And how about the Z-axis? Yes, the Z-axis, there's a movement, so we need Z-axis and the spindle we need to delete. And the spindle delete. Let's attach the Z-axis again. Body, yes. It is head, and is a head. And next will be the spindle. Attach simulation body. Is a head, and is a head. Okay, right, that's the head, and the spindle we have done. What else have moved? Yeah, the y-axis. Okay, so the y-axis, so we need to delete this y-axis. Add the new y-axis now. Y-axis is others. What else? The rest is the same. Okay, and we need to change the two positions. And this one we already moved by y 228 and x minus 381. So we need to set here, and after set here, then click here, and we're going to change the inter-op operations. This is a default retract, right? I'm going to edit this one. You can see that Z absolute, that means when to change, you will move the Z to these positions. Absolute, that means the current position of the components. The default is X and Y is user, that means you can set the to change position in the document control. So since we already moved the component to a to change positions, I don't think we need the user to set this value unless you need to. So I'll put 0 and 0, refer to the current positions. And of course A and C is not moving. Flow end, this is a retract for the flow end. Yeah, flow end. Again, so I'm going to set the same thing. I'm going to use absolute and absolute. It was after finish. You can choose the XY not move also if you need. So now I just change both AC is okay, short angles, and okay, right? Then save. And let's do simulation now. Select this one to see the new behavior. Right, rewind. You can see that now the machine actually start at the to change positions, the initial position of our machine model, and then it will go to this point XYZ, and then go down, and then go up and go back to the XY to change positions, then chain 2 and come back again and continue the machine. Okay, so next we're going to test for 5-axis move. Let's hide this. Right, we're going to use the XY planes, and before that I'm going to show the edge, and I'm going to extract this edge here, then off the edge display, and I'm going to use it's one of these two, and 5-axis. Right, so I'm going to use the XY plane, surface path. I will use the project curve, and select the drive surface, use control key, and make sure on the face filter, control key to choose this 3 drive face. Okay, and projection line, and let's choose this line here as my projection line. This setting is okay, default. Go check, no need. And this is okay. The retract here, this is a clearance. We got put at 50. Don't want it too high. 50, and then okay. And do it. Right. And I should have a lines. Oops, it looks like the lines high. Let's change the length again. Retract 500. I just want 50, not 500. Then okay. Let's recalculate. Yeah, that's what I want. Okay. For the testing, first I'm not going to set any limits, right? No unlimited limits. Let's do a simulation. And skip unselected operations. Let's just do a simulation only on this 5-axis procedure. You can see the tool actually moving from one side to the other side because I don't control them. Because the tilting angle I select from plus 120 and the minus 120. This is the default. right? And normally this is quite a dangerous move. Of course, you can always set the preference again. I can always set, like, for example, I want just the minus side, means using this angle range, and then rewind. And play. Let's play continuously. You can see that the GibbsCAM will automatically swap the tool if the angle limit is reached, so that the movement is always 0 to minus 120, right? This shows that the 5-axis move is working properly, and the machine is ready to use. Next, I'm going to show you how to save all your files into a GibbsCAM package file. Sometime maybe you need to, for example, if you need to send, you need a post processor, right? So you need to send the machine that you built with the MDD to us, so that we can generate a post processor for you. So where's the files? So you can use the Pathfinder. If you want to do it manually, you can use a Pathfinder find. For example, the machine folder contain the machine file, like this one, right? So you just copy the whole folder and send to us, but this is manually. And also you have to remember to send us your MDD also. It's under the all user MDD. So let's look at HAAS here. HAAS 5X. HAAS 5X somewhere here. Yeah, here. So yeah, so for 5-axis machine, normally you just need MBD and of course the machine simulator. You don't need a VMM. For MTM, yeah, you still need a VMM files, right? Yeah, that is how you do it manually if you want to send the data to us. Another way to package everything into a file, include the machine simulator and MBD, is to use the pack and go, right? So you just either choose all file or select the file, then you can choose which one to pack or which one not to pack. So let's choose all files and create package and save into a GC13, then save. Right, this is the easiest way. Right, let me close the file. Okay, the package, this is the package file. The package file is actually a zip file. You can open with any zip software, for example the 7-zip software, and then you can see everything inside, including the part and the machine chain, the machine simulator, and if you have intermediate tooling, everything is here. and when I receive this file, I can always just pick and drag and open with all the setting that you set, right? So that's the GibbsCAM package file. It is very useful for a complex machine.